All right, today's continuation of Pythagorean theorem is how we apply it to our trade in a way, because we need to always apply it to our trade. So this is what we're going to do. We need to understand the terminology that's associated with triangles. So on any right angle triangle, if we're talking about this angle right there, we call this side the side adjacent. And what that indicates is this line. We're calling this line the side adjacent to this angle. This line right here now becomes the side opposite. So the side opposite would be this line right here, and it's the side opposite to that angle. And then finally, this line right here, we call this the hypotenuse. So this line becomes the hypotenuse. So it's very important to get that terminology correct. So if I had a right angle triangle, and if I was talking about this angle in the corner, I would call this then the side opposite. The side opposite the angle. This becomes the side adjacent, and this is the hypotenuse. So you can see how, depending on what corner or what angle we're talking about, it has a difference in the terminology. And that's important as we get more and more towards trigonometry. All right, so now that we know that, in the trade, we actually call these sides, we have names for these sides in the trade, and we would call, on a right angle triangle, we would call this line right here, this line right there, we would call that the run. Okay, and we would call this line right here, we would call that the rise. Now, a lot of times we also use some terminology like the set or the offset. We could call that line. And then this line right here within our triangle, we call this the travel. All right, so those are the three things. Now, to recap from yesterday on Pythagorean theorem, a squared plus b squared is equal to c squared. And we can manipulate that formula any way we want. If we want to solve for b, we would go c squared minus a squared is equal to b squared. And if we wanted to solve for a, c squared minus b squared is equal to a squared. So that's important from one part of that assignment. The other part of the assignment is using a right angle triangle that has 45-degree angles. So any triangle has a total of 180 degrees in any right angle triangle. If we're talking about 45-degree angles here and here, we could then surmise that A and B A and B are always same value in a 45-degree right angle triangle. Okay, A and B are always the same because that would say right back to Pythagorean theorem. Now, A and B are always the same in a 45-degree right angle triangle because clearly if it's 45 degrees, we are simply having a perfect square and we're cutting it in half. Okay, so that's why A and B are always the same in a 45-degree right angle triangle. The next part that I want to explain on a 45-degree right angle triangle. So if this is 45, the right angle, the run and the rise are constant. The travel, however, becomes 1.414 times longer. We need to keep that always. That's a memorization number. We need to know that at all times, that the travel is always 1.414 times longer than the run or the rise. And we will prove that. We'll use this red marker to prove that. So if the run is 1 and the rise is 1, then that would have to equal c squared as the travel. And that's Pythagorean theorem. So that would be 1 squared plus 1 squared equals c squared. So 1 times 1 is 1. 1 times 1 is 1. It's equal to c squared. So 2 is equal to c squared. To get c, then we square root c squared, square root 2. C is equal to 1.414. So we always maintain that. We always have that. That's our constant number. Travel is always 1.414 times longer than the run or rise. Good. So the second part of this is let's try to use some of these numbers to solve for our travel. Okay, so we have a right angle triangle, and if I said that A is equal to 10, then B has to equal 10. And how far is the travel? Oh, we go 10 times 1.414. The travel is equal to 14.14. So let's do a different one. If I had a right angle triangle and I said the travel was 150 mils, how much is the run? We can now take 150 and divide it by 1.414. And then the run would equal 106.08. So we use this a lot in the trade. We use this. So there's a couple of examples. Now you should be able to finish assignment 9. Thanks for listening, and we will talk to you